Hey, 8th grade, happy Monday. So today we're going to start talking about predicting motion and calculating force. And our main question is going to be what causes an object to move? So let's start with just talking about what is a force. It's a push or pull that can cause the motion of an object to change. Now we're going to talk about something called a free body diagram. And free body diagrams, they show forces on an object. And they include gravity, which would be a down arrow, a normal force, which would be an up arrow, applied force, which is an arrow to the side, and friction, which is an arrow to the opposite side of the applied force. And this will make a little more sense when you see it in a visual. So you see the normal going up, the gravity going down, the applied going to the right, and the friction going to the left. Same here. You have normal, you have gravity, and you have friction in the direction that the bike is moving because of the tires. So what are forces? What types of forces are there? Well, there's balance, which means that the net force on the object is zero. So the object isn't moving or it's moving at a constant speed. So if there's no net force in one direction, it's either not moving or it's moving at a constant speed. Or there's unbalanced. And this means that the net force in the object does not equal zero. And there's a change in the object's direction or speed. So balanced forces would be two people of the same size and strength pushing on this box. It's balanced. The object is not moving. Unbalanced could be something like the truck speeding up in the direction right. There's a small force, possibly wind, coming from the front of the truck, and the bigger force coming from the back of the truck. So there's a net movement or a net force to the right. So when we combine forces, you need to figure out what direction the force is moving in. So like in this first one where you see we have two forces both pushing to the right, it becomes a bigger force pushing to the right. If there's a lot going towards the left and a little coming towards the right, you'll notice that the difference between the two forces is what's left over. Same here when you have two things being pulled apart. The stronger force, or this blue force, it shows the direction it would go and the difference between the two. And we have our balanced force where both are the same. You can picture this bottom one like a game of tug of war. So the net force is the overall amount of force on an object, and it needs to have direction and magnitude. So how hard, or in newtons, and in what direction. So it's measured in newtons for units, which is written as a capital N. So an example might be 25 newtons to the right. So when you calculate net force, if two arrows are pointing in the same direction, you add the force together. If they're going in the opposite direction, you would subtract. So let's have an example right here. We have some forces on the left and some forces on the right. These ones on the left, the first thing we need to do is add them together. When we do, the right side equals 1,550 newtons. If you're to move over to the left side, we're just going to drop that down because it's the only one on that side, which gives us 1,563. Since the right side and the left side are on opposite sides, we're going to subtract, and that leaves us with 13 newtons right. You're going to be doing more of these free body diagrams as well as drawing some on your own based on word problems. Go ahead and get started on your packet for the day. Your exit ticket is on paper today.